Hello, this is Mr. Claudy, and today we're going to be going through our first section of the electricity chapter. The section is on electric potential difference, which you might also know as voltage. So you can go through the slides. A lot of it is a grade 9 review, but it's good to be refreshed. Maybe you didn't cover this content in as much detail in grade 9, so make sure you take some time to get used to these concepts. Electricity is a little tricky because it's very invisible. We're going to be looking at the formula for electric potential difference, which is the amount of energy. Remember, a lot of concepts go back to that energy chapter we did. So we're looking at voltage, or the potential difference, as an amount of electricity per charge. So let's do some examples. In order to start a car, you have a 12-volt battery that supplies 1,230 coulombs of charge. How much energy is used to start the car? Okay, let me just make sure I have my calculator somewhere handy. Oh, there it is. Okay. So we know the voltage, or the potential difference, is 12 volts. When you go into the Canadian Tire, that's the type of battery you have to get for your car. And this coulombs, that's an amount of charge. That's Q. 1230 C. And we want to find the amount of energy. So we're going to use the formula. Voltage is equal to delta E over Q. I can sub in my numbers for 12 volts. E is what I'm trying to solve for, and Q is 1230. So when I cross multiply, I end up with 12 times 1230 gives me 14,760. So therefore, let's say two significant figures, 1.5 times 10 to the 4. What are the units again? Well, this voltage is in volts, Q is in coulombs, or charge is in coulombs, and energy is always in joules. So 1.5 times 10 to the 4 joules. Remember, we talked about joules. That's like energy. That's like drinking Red Bull. It gives you energy. So this is how much energy that battery supplies to all of the little charges in the wire so that the car can start. It's kind of like the amount of juice that you're giving to each charge. Okay, we have another question. A 450 watt kettle is used to boil water for 4.25 minutes. Calculate the amount of charge passing through the kettle if the potential difference is 120 volts. A lot of confusing terms here. Let's go through them one at a time. 450 watts. Well, if you remember, that's from our last chapter, or last section. That's power. And remember, watts can also be written as the number of joules per second. Remember, we looked at the difference between a Lamborghini and a little car. It's not about the amount of joules, it's how many joules per second. So that's how I remember power. Then we have 4.25 minutes. Now, we know that that's going to be a problem. Nowhere do we ever use minutes. So I'm going to multiply that by 60, and I'm going to get 255 seconds, which is probably something that I'm going to have to use. Calculate the amount of charge. Well, charge is what we're trying to find, so that's Q. And then the potential difference, which is a nice way of saying voltage is 120 volts. Okay, so if I want to find Q, well, the only formula I know right now is V is equal to delta E over Q. I know what V is, but I don't know what E is. So how can I find E? Well, we know that this is how much joules per second is happening, and then we know how much time it's taking place. So I could use the power formula, which is change in E over time. So then I have 450 is equal to delta E over time in seconds, which is 255. So I cross multiply, and I get 450 times 255, which is 114,750 joules. That's a lot of energy. That's a lot of Red Bull. And then we're going to plug that into this formula. So now I have 120 is equal to 114,750 over Q. So Q, if I cross multiply, is going to be 114,750 divided by 120. And I end up with 956.25. Therefore, probably two significant figures, so 9.6 times 10 to the 2. What's the unit for charge again? Oh, it's C for Coulomb. Now, electricity is a little bit confusing, especially to learn on your own. I just want to draw your attention to a useful analogy, and I'll keep coming back to this throughout the chapter. But the way I like to think about, there's a few different things we're going to learn, so voltage, current, and resistance. Today we're just looking at voltage, or potential difference. Think about voltage. One way to think about it is like water in a system. So voltage is a certain amount of height for these electrons. It's how high they are. So how high up they are. Then as they go through the river, when they get to a water well, they turn the water wheel and they drop down. So they have all this energy up here, this gravitational potential energy, and then they drop it, they transfer it to the water wheel and they go back down to a low section. That's how voltage is. Think of it as, instead of electric potential energy, electric potential difference, you could think of it as gravitational potential energy. Another way you can think about electricity or voltage is each of these charges gets some money. That's the voltage. So you give them each $50 and then they go through a circuit and they spend that $50 somewhere. So again, the voltage is not how fast the energy is moving, it's how much juice or how much energy or how much money each electron has. So hopefully that will be a useful analogy. We'll come back to that in the next section. That's it for now, and we'll see you next time.